Okay, so let's talk about a couple more terms. Polarity. Okay, so when a sound is produced, we start with a positive wave. Okay, so we talked about how this is all waves. So here's our even line of silence. Okay, there's no sound. Sound is produced. It makes a positive wave first, and then into a negative, and then a positive and negative again. And that's why it's called a wave, not just a hump. Okay, it's positive and negative. It's push and pull. Okay, and so talk about polarity as it relates to that.
So back to my definitions. Polarity is the binary term meaning the positive versus the negative amplitude orientation of the waveform. So you can have...
Say that in layman's terms.
Okay.
That was a great definition. Just break it down a little bit more.
With electronic signals, just like electrical signals, you have positive and negative. Right. So one is the inverse of the other. If you were to, well, we do not recognize audio polarity until you hear the same source twice. That's the caveat with audio, unless you have a measurement system. So if you had two same sources, like classic example, snare top and bottom microphone, same source, two microphones, and they're spaced differently. If I were to invert the polarity on one of those, sonically, if both of them are matched in amplitude, and by amplitude I mean level, volume, or SPL, sound pressure level, you would sonically hear a difference. But the way our ears work, we have to have a reference and then a second source. And so the way you would actually hear polarity would be two sources at the same time with polarity, meaning the pins are now reversed. So like an XLR, right? You have three pins. The USA standard used to be pin 3 hot. The rest of the world was pin 2. Now everybody's on the same page. Pin 2 is hot. Not super important for you to remember, but when we get into polarity, we're physically talking about a 180-degree reversal across all frequencies. And when we touch on phase a little bit later, that is frequency dependent. So polarity on like a soundboard, when somebody says reverse the phase, you're not changing anything about the time. You're literally taking pins 2 and 3, swapping them electronically, and reversing the current.
Yeah, so I'm going to break down that snare thing he just mentioned.
Yeah.
Okay, so on a snare drum, okay, we got a microphone on the top and a microphone on the bottom. So they're kind of pointing at each other, okay? So when the drummer hits the snare, those heads move, and that creates the waves, a positive and a negative, okay? So microphone on top, he hits it, it actually gets the negative first because the sound is going away from it. So the top head actually gets the negative wave first, but the bottom head is getting the positive because the air is going that way. As he hits it, the air is moving that way. So the bottom mic is getting a positive signal first, whereas the top mic is getting a negative signal first because the air is sucking out. As he hits the head, it's creating a vacuum almost. Okay, so now they're getting this one. The top mic is getting a negative signal, and the bottom mic is getting a positive signal. That's out of phase. Okay, so that would essentially cancel one another out. Okay, so we reverse the polarity and tell the bottom mic, don't listen to that positive mic first. I want you to listen to the negative first. So it's like it swaps it. So now they're both listening to negative at the same time. So that puts them back in phase. Because if one was going positive and then negative, and the other one's going negative and then positive, they just cancel out. And it doesn't actually create silence, but it does remove a good portion of it. And so by flipping the polarity, it reverses that by 180 degrees. So instead of listening to a negative first, it would hear a positive wave first.
Yeah, and a good way to visualize that is take a slinky, and you do the classic, ripple the slinky. And if you were to look at that in like a high-speed camera, you would actually see what we call the compression part of the longitudinal wave. You'd see where the slinky compresses like that. That's, in audio, we call it the impulse, because it's where it compresses the most in the wave. So if you had two slinkies now, so two microphones, same source, and you start one slightly ahead of the other, the waves are not going to be the same. The compression points in the waves are not going to be the same, and at some point in time, they're going to cancel So that's a good way to think of polarity as well, is two waves and the peaks and the crest are occurring at different times.
Great. So you guys came here to learn about slinkies. Does that make all the sense?
Yeah, go buy some Slinkies.